Solution for COVID-19 pandemic. Introduction. COVID-19 pandemic has disrupted the way of life of nearly every person in the world. The practices may have once overlooked, such as cleaning, disinfecting methods used in homes, office, schools, and public spaces, are now widely discussed topic regarded as essential measures to protect COVID-19 and ensure the health, safety, and well-being of all those who interest in buildings and spaces. Chlorine gas. Chlorine is a yellowish greenish yellow gas. By providing high pressure, the gas becomes liquids. It is toxic. The chlorine gas is mostly used as water disinfectant. Introducing chlorine to water plays a very effective role by removing almost all pathogenic microorganisms. It can be used both as primary and as secondary disinfectants. The gas is not applicable to be used in household systems as it is very dangerous. It is lethal at concentration at as low as 0.1 percentage air by volume process. Chlorine readily combines with water components, that is chemicals, small animals, microorganisms, plants, odors, colors, and tastes. Sufficient quantity of chlorine is necessary to meet with the demand of chlorine in water and provide residual disinfection. Residual free chlorine is termed as the one that does not combine with other water component. The point at which the free chlorine is available for continuous disinfection is termed as the breakpoint. The system at which free chlorine is supplied at a concentration of 0.3 to 0.5 mg per liter is an ideal system. Simple test kits, most commonly the DPD chlorimetric test kits are available for testing breakpoints and chlorine residual in private systems. The kit the kit must test the amount of free chlorine and not total chlorine. Chlorination. Sodium hypochlorite solution. Sodium hypochlorite is used as bleaching agent, mostly to bleach papers or textiles, and such as a disinfectant in a solution. The solution generally contains 10 to 15 percentage of available chlorine, but rapidly loses its force in storing process. Regular controlled environment is needed as the solution is affected greatly by the pH, light, heat, and heavy metals process. Those dosing systems are mostly simple, but there might be a concern regarding the design. The design might influence the control of gas released from the bulk hypochlorite in dosing pumps and piping and scale formation. Gas gasification mostly produces oxygen can lead to vapor or gas bubbles formation, specifically if sodium hypochlorite is at below the atmospheric pressure, which leads to gas locking of suction line in a diaphragm. Pumps should therefore be provided with flooded suction. Tanks must be properly vented out of all structures to the atmosphere. Most commonly available dosing systems use diaphragm metering pump. The pump action can lead to developments of vacuum. The vacuum causes vaporization of dissolved gases in sodium hypochlorite, resulting in the pump losing its prime and lower applied chlorine dose. Consequently, to aid in prevention of gaseous gasification, the dosing arrangements must have positive head on the pump suction. In addition, piping system configuration which will trap sodium NaOCl between closed isolation walls and or check valves should be avoided. A calibration cylinder, a pulsation damper, a pressure relief valve, and a loading valve are the main components of a dosing system. Automatic auto degas valve systems are also provided by some dosing pump suppliers. NaOCl is dosed either through a spreader bar submerged within an open channel or through an injection fitting. The pulsation damper and the dosing pump should be placed close to each other. Pulsation damping also helps in improving dispersion. A loading valve should also be provided in system where back pressure at the pump delivers is not sufficient. Till a, till a suction demands valve is installed in suction side. For protecting the diaphragm from the rupturing, a PRV pressure relief valve should also be provided on the delivery side of the pump. PRV's operation must be detected and alarmed. Example, the outlet of the valve could be directed to a small catch pot equipped with a float switch. All the system or pump which are shut down should contain methods to relieve any pressure build-up. As sodium chloride hydroxide is used in its manufacturing, the pH of the NaOCl is high. Extreme care is needed when using hard waters, as the highly alkaline products can lead to lower flow rate, reduced pipe diameter, reduced pump capacities, and scale formation at dosing. Chlorination, sodium calcium hypochlorite, CaOCl2. Calcium hypochlorite is an essential solid that can be used in replacement of NaOCl as a disinfectant. It is similarly with NaOCl, but it is much safer to handle. Almost 70% of chlorine is available in commercial grades as CaOCl2. It has it has applications in both wastewater and drinking water process. The calcium hypochlorite chlorinated contains a cylindrical polyvinyl chloride tank with a height of 0.6 to 1.2 meter and a diameter of 230 to 610 millimeter. A CV plate is present containing a holes that supports 80 to 80 millimeter diameter CaOCl2 tablet. Tablet chlorinated systems can usually provided between 1 and 295 kg of chlorine per day. At the bottom, a side system is piped into chlorinated. The flow arises from the hole in a CV plate that results in eroding the last layer of tablets. The amount of water entering the chlorinator is proportional to the rate at which tablets erode. The rate of chlorine dosage can be calculated by controlling the water flow through the chlorinator. To meet the operational requirement, the chlorinated effluent is returned to main stream, providing the desired level of available chlorine. Variation in the dose and the contact time can be done to calculate the required disinfection. Different factors affect the chlorine dosage, that is, wastewater characteristics, the demand of chlorine, and discharge requirement. Mostly the dose range from 5 to 20 mg per liter. Different factors account for the optimum disinfection, that might include temperature, alkalinity, and nitrogen content. The pH of wastewater might affect the distribution of chlorine between hypochlorous acid and hypochlorite. A lower pH favors the hypochlorous acid, a better disinfectant. Higher concentration of hypochlorous acid will lead to formation of hazardous chlorine gas. Chloroamines are Chloroamines are formed by reacting ammonia with free chlorine. They play an important role in providing residual protection in distribution system. They are very stable in comparison to chlorine. Fewer halogenated byproducts are formed. Ozonation. Ozone is an allotropic formula of oxygen in which three molecules are combined to produce a new molecule. It quickly decomposes to generate highly reactive free radical. The ozone oxidation is greater than the chlorine or hypochlorite ion substance widely used in wastewater treatment such as oxidant. Ozone is surpassed only by the hydroxyl radial and fluoride in its oxidation capacity process. Ozone is produced from a gas containing oxygen. The gas is then passed through an electric field. The air is treated to make sure that it is dry and free from dust impurities. Oxygen is converted to ozone in an electrical field. The ozone is then fed to contact tank so that the ozone is dissolved by water to proceed disinfection process. Conclusion: the COVID-19 pandemic has created a number of ongoing challenges to people to share public spaces. People are anxious about the safety of shared spaces and seek validation that the space has been cleaned and disinfected before they enter. More people are participating in cleaning and disinfection process. Thank you.